squared. Zero. Okay, Cindy, you need to come up here and do your middle finger tricks for zero. I don't see where the zero is coming from. Maybe you need to show me. Huh? It's like infinity. Is it like infinity or is it infinity? It is. It is?
I don't know.
Does anybody know what infinity is? If you don't know, then how can it be unique? Right? Can it be unique?
Does not exist.
Does not exist. Now, the thing is that in the book, okay, in the book it will be classified as does not exist. If you put down infinity, I'm okay with it because in calculus we will probably be using that concept. Because all we want to know is what's happening to the function. By making this statement, you are saying that the function is just blowing up. Okay? So you get some sense that, hey, it's blowing up. If you want to say D and E, you have no idea. Is it because the things are not connected, or is it going to hell? Or heaven, I guess, going on. Right? You don't quite know. So either one I will accept. Either one. So this could be D and E, which is the book's preference, and I could do either. Wow, is this topic putting you to sleep, man? Ashna, Ryan, it's not that. I think it's probably what you had for lunch. What did you have, dalbat? Then how can you fall asleep? Hey, you know what I had today? I had eating right. You know those frozen dinners?
Oh, yeah.
But it's chicken methi malai. Yeah, seriously.
Oh my god, where'd you get that?
I think my wife got it out of Safeway or at Bharat Bazaar. I'm not sure. One of the two. Yeah, one of the two. She got that. Yeah. It was good. It's good. Yeah, it's good. All right, everybody get the idea of D and E. Susie, Lena, did you get D and E? Okay, using Nbox. So get your Nboxes out. Okay, get on task here, guys. Come on, get on task. X minus 3. Put it in Y1. Graph that. Shh. Cindy, this is being recorded. X minus 3. And so if you want to look at the graph, your answer to this question here, a limit as x goes towards 3 would be, your answer would be 0. Doesn't, okay, I mean, does everybody see this?
I think mine is still not.
Okay, as you are going along the graph towards x equals 3, that's what's happening to the graph or the function. If you go on the other side, it's also going towards 0. Okay?
Here's the other part.
I know, I don't care. It's a 0 as well. Alright, is everybody okay? Now what I want to do is also take a look at it in an alternative way, and the way to do that is to look at the table. Oops, sorry. You had to walk all the way around. I'm sorry. Yeah. Oh, Erica. Yes. Can you reset your calculator? Cindy, do you know how to reset our calculator? Okay. So, in some instances, you'll be asked to actually do a table. And the table might look like this. Got it? Cindy? Okay, you want to fill in the table? Well, to use your graphing calculator, this is how you do it, okay? You go second table set, select your start value. I'm just going to select the value -3 for the heck of it. And the key point here is to make your independent variable ask instead of auto. Ask. Because then if you go into table, you can put in 3.01 and you get the y1 value right there. Am I going too fast here? Okay.
Why am I only seeing X?
Independent, because that's the x value. If you want it to be 2.5, you just enter 2.5. Okay, you guys paying attention here? Okay, I have a lot to do. And the answer is -0.5. Okay, and you can make a table like that. Well, even with the table, I'm going to go back into the auto mode now, okay, just to show you what the table looks like. So now if you look at the table, you want to see what's happening to the function as x goes towards 3. Okay? Well, remember, you want x equals 3, right? Not x equals 0. Okay, right there. Okay? So if you look at it here, you can see that the function value is going towards 0. And you can see on this side also it's getting smaller and smaller and getting towards 0. So they meet at 0. Okay? They meet at 0. So then the limit of that function would be 0. Okay? So the answer to this would be 0. Okay? So everybody with me on that? Okay, let's look at some other examples now. Okay? What happens in this case? Yes, I'm going back then. What happens in this case? So put this in your n box, 7 over x minus 3. Yeah. Anybody need any explanation on that? Right, because in one side it's going towards plus infinity, on the other side it's going negative infinity. So it does not exist. Yeah. At a unique number, one number. Infinity you don't know is a number, so how can you even say it's unique? You don't know what it is, right? Yes, yes. Okay, is everybody here? Okay, some more examples coming up. Did you graph it? Okay, another example. So I'm going to kind of zoom in there because it's not giving me enough details. So I'm going to do zoom box. Do you see why I use the word oscillating? Yeah? Do you see it's kind of doing that? Yeah? So if it's doing that, do you think it's going towards some number? I mean, it's doing this stuff here. Right? Oh, my bad. Okay? Yeah, see, this one doesn't work. This one doesn't work. Yeah, now you understand. Okay? So since it's oscillating, there is no limit for this function. Does not exist. For this one here, does not exist. Sine 1 over x.
So it only exists for really.
They have to be meeting at a place. Yeah. Right? Isn't that the example that we just talked about? All right? Okay, now we're going to do it algebraically. So now algebraically, you may think it's really tricky and challenging, but it's not. It really boils down to plug it in, plug it in. Okay? Boils down to plug it in, plug it in. The only time you have to worry about plugging it in is when the denominator becomes a when a bad thing's happening, when the denominator becomes what? 0. Okay? When the denominator becomes 0, bad things happen. Okay? Well, in this case, does the denominator become 0 when x is 3? No. So you're okay. You can plug it in. So if you plug it in, this is what you get. Can someone tell me what that is? $10. Use your graphing calculator to see that that is indeed the case. Huh? Okay, do it. Do it. Someone going to help me factor this, Layla? Well, I'm running out of time here, okay? Who's going to help me factor this? Yeah. Okay, so we're going to take some steps here. Is everybody okay there? And then can I pull an x minus 1 out of there? Get x squared plus 1 over x minus 1. Can these guys cancel? Okay. Now is it okay to plug in x equals 3 in here? Hang on, let me finish. Is it okay for me to plug in x equals 3 in there? Do bad things happen? What's my answer? Isn't that what we had? Okay. So in other words, what it's saying is that if you can factor and cancel, you can avoid bad things from happening. Okay? Question, Krakow. Yeah. What about the 3? I'm saying what you're left with after canceling is this function. Okay? And if you plug x equals 3 in there, bad things don't happen because there is no denominator. Then bad things happen. Not. Oh, this one. No, this one doesn't happen. Can I finish here? This one's okay. Everything's okay on this one. Everything's okay on this one. Okay. The next example will be different. So just watch. Okay. Watch. Allison, this one here. It's not 3. It's 1. Okay. So you cannot put in 1 here. Okay. All right, you guys see that? You cannot put 1 in there because bad things are happening. Right? Everybody see that? So now we can do it by saying I'm going to do limit x goes towards 1, and I've got x squared plus 1 times x minus 1 over x minus 1. Everybody okay on that? So it's the same factorization that I had before. Sorry? I've changed the question. The first question was limit x goes to 3. This is a question limit x goes to 1. It's a different example. Example 2. The first one was example 1. Okay? So now I can cancel this guy. All right? I can cancel that. Is everybody with me on that? Do bad things happen if I put in x equals 1? What's my answer? Is that what you get in your graphing calculator? Do it. Did you graph it? Yeah? What did you get? You got 2 graphically and table? Both ways, nice. Okay, is everybody with me? Krakow, you had a question. Yeah. Krakow, you had a question. It's the same kind of example. No, you take x squared out of here, right? It's the same example. It's So if you take x squared out of here, it becomes x squared, x minus 1 plus x minus 1. Right? So then these two are the same things. Yeah. So when you take this out, you get this. And when you take this out, you know there's a 1 here. So you get that. Okay? All right. I'm kind of rushing through this, I know, but that's life at the end of the year. Okay, 2 boxes that you need to copy and get them in your notes, and then I have one more example to do, and then I'll be done. So I'll just barely make it. Okay? So, number 47, page 790. Anybody want to give me an answer for this one? Anybody want to give me an answer to this one? Anybody awake? And the answer is... And the answer is... Negative what?
The same thing that's there.
What do you mean same thing that's there? Joanna? Negative 12, and pray, Joanna, tell me what property makes you say that. Number 1, scalar multiplication or scalar multiple. Okay? Next one. What was that, Cindy? 9, and what property? Tell me. Number 2, addition or sum. Okay? And then the last one. Mina, the last one. What's the answer and what property? Remember, this is the same thing as limit x goes to c of f of x to the 1/2 power. Right? Square root is 1/2 power. What do you think this is now? I've given you more than a hint now. Square root of 3. What property number? Number 5. And the name of the property? Power. Is everybody there? I'm done for the day. Oh, well, for this period.